Hey guys, I'm Jade. Today is my LeetCode review vlog on the 452nd problem. Minimum number of arrows to burst balloons. There are some spherical balloons taped onto a flat wall that represents the XY plane. Arrows can be shot up directly, vertically, from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x start is less than or equal to x and x is less than or equal to x end. We are given the array points. We have to return the minimum number of arrows that must be shot to burst all balloons. Let's see example 1 here to understand it easily. We got the input points 10 to 16, 2 to 8, 1 to 6, and 7 to 12. And the output is 2 arrows. This is because the balloons can be burst by 2 arrows. The first arrow shot at x equals 6, which will burst the balloons at 2 to 8 and 1 to 6. And we'll shot another arrow at x equals 11, which can burst the balloons 10 to 16 and 7 to 12. Then, let's get started with our intuition to solve the problem. So the key point is greedy algorithm. We can sort the balloons based on their end coordinates, and then we'll shoot an arrow at the end of the first balloon. And this arrow will burst balloons as many as possible. We then will continue this process for the remaining balloons. And we can also notice that sorting the balloons by a start position in descending order and shoot at each balloon start position is equivalent to the above solution. Then, let's get started with our intuition to solve the problem. So the first step is we have to take care of those edge cases, which is if points.length is equal to 0, we just return 0 because we don't need any arrow to shoot the balloons. And the second step is we have to sort the points array. We'll use the arrays.sort method with a custom comparator to sort balloons based on their endpoints in ascending order. So the code is points and a comparator. AB arrow integer dot compare of A of 1 and B of 1, which are their endpoints. And we have to sort them in an ascending order to guarantee shooting from the leftmost or the rightmost balloon, which obeys our suboptimal assumption of greedy algorithm. And this is the second step. And for the third step, we'll create a variable. Let's call it arrow count. And we start it at 1 because we'll use 1 arrow for the first balloon. And for the next step, we'll create a arrow position and start it at points of 0, 1, because we have to get the position of the first arrow at its endpoint to ensure that each arrow will burst balloons as many as possible. And for next step, we'll iterate through the sorted balloons with a for loop. Let's say for int I started at 1 and I should be less than points dot length. And we have to increment I after each iteration. Inside the for loop, we have to check if the start of the current balloon is greater than the position of the last arrow. If so, it means the last arrow cannot burst this balloon, so we need another arrow. And the code is if points of I 0 is bigger than arrow position. In this case, we need another new arrow, so we have to increment arrow count plus, and we also have to update the arrow position with points of I1. We have to update the arrow position to the end of the current balloon. And on the other situation, which means if it is not, the current arrow can burst this balloon, so we'll do nothing and continue the iteration. So we'll skip it. And out of the for loop, we just return the arrow count. And then let's check for the correctness and analyze our time and space complexity. So the time complexity, it is big O of n times log n. This is because we use a quicksort algorithm to sort the points array. And yes, our code got accepted. And the subsequent single pass through the balloons will take big O of n. So the overall time complexity, it is big O of n times log of n. And for the space complexity, it is big O of log of n, because we use the quicksort algorithm to sort the points array, which takes log n time complexity. And thank you guys for watching. This is my LeetCode review vlog on this problem, and I really recommend you guys to visit my online GitHub page here. You can see all the notes for the top 115 LeetCode problems. You can see the problem description, intuition, Java code with annotations, and the final complexity analysis. You can also visit my GitHub repository here, which contains the codes and notes to build the online GitHub page. And thank you guys for watching. And I'll put those two links on my YouTube description below. And see you next time. Bye bye.